So this is another sample graphing with derivatives problem. It was a little bit messy, but I already selected it, so I went forward with it. It's a fourth degree polynomial. The first step is to find y prime. Y prime in this case is 4x cubed minus 36x squared plus 84, found by the power rule. The second step is to set y prime equal to 0 and solve for x. So this is not factorable, and so what I did is I plotted it. You can either plot it and look at where the roots are of this function, where this guy inside crosses the x-axis. What I did is I just told my computer to solve it. You can put it on Mathway and set it equal to 0 and solve it. Whatever I give you on the quiz will be factorable and solvable. So here it was not nice numbers. We had three numbers, x equals minus 0.142, x equals 1.696, and x equals 8.72. The next step is to find the y values, and they're pretty scary. You can plug it into your calculator and quickly find all the y values. Notice that we have minus 1,438.3. I don't think you can see the point there. So these are huge numbers in magnitude. So these are my three critical points. The critical points are where the derivative is equal to 0 or where the derivative does not exist. In this case, the derivative exists everywhere, so we don't have a problem with that. Next is to make your slope chart. So you lay the x values of this critical points on the slope charts. These were the x values of the critical points. Recall in the previous problem where I had the graph and I drew the slope chart from it, they were the bumps. These are the bumps. So we are placing the x values of the bumps on the slope chart. And we need to find out what goes on in between each one of these arenas right here. You must label the slope chart, because if you don't, I have nothing to go by. So I'm not going to give any credit for a slope chart, even if it looks like the graph, if it doesn't have labels on it. Next, we're going to have this table that we're going to choose numbers in between each one of these cutoff points. And for example, I'll choose a number here in this region. Well, minus 1,000 is in that region, and I chose minus 1,000 because it's so large I can eyeball the answer without actually plugging in. I'm also going to choose a number in between these 2 points, and that's 0. I'll choose a number in between these 2 points, that's 2. And then finally, I'm going to choose a number in this region, I choose 1,000. Now, some of you had chosen the critical points here in this table and then put plus minus signs. If you do that, I'm going to have a standard cut, which is fairly high, because it's, first of all, it's a sign that you really don't know what's going on. And second, you wouldn't plug in the critical points at all in this table because you're trying to find the sign in between the critical points. So it's a gross error in some ways. It's a lack of understanding of what the overall goal is. Now, if I put a negative 1,000 in here, this number here is going to be so huge and negative, it overshadows these two other numbers, and the sign of what I get is negative. So I didn't need go no further. 0 is easy to plug in. I see that the derivative is 3, and that's positive. 2, I actually did have to plug in, and I used a calculator, and I get minus 28, which is negative. And 1,000, well, I have the same reasoning here. If I put 1,000 in here, this number is so huge, it's going to be positive at the end of the day. So now I have the signs, and with the signs, I put the signs in here first, and then I put the according arrows. Now, when I had the graph already, I was going the other direction. I had the graph, and I drew the slope chart. I did the arrows first, and then I put the sign of the derivative, because I'm going backward, actually. Here, I have the signs of the derivative, and they tell me whether the arrows are going up and down. Now, next step is to take the second derivative. The second derivative is nice and clean. I can factor it. An x can factor out, a 12 can factor out, and I get 2 points here. I get x equals 0 and x equals 6. I do have to find their y values. X equals 0 is easy. I plug it back into the original function because I'm trying to graph the original function, not the derivative and the second derivative. And I also put in the y value for 6, and I get y equals minus 788. By the way, those are my local, my possibilities for inflection points. It doesn't necessarily have to be an inflection points, but they're potential inflection points. Now I make a y double prime chart, just like I did before. They have to be labeled. If they're not labeled, I can't give credit because I don't know what it is. I do the same thing I did for the first derivative with the second derivative. I write down the signs, and this is not the correct second derivative, that's the correct second derivative right here. I write down the signs and I choose in values. Minus 1,000 is before 0, 1 is between 0 and 6, and 1,000 is after 6. So I choose these values, and if I plug in negative 1,000 here, it's so large and positive because of the square, I'm going to get a positive answer. I just ignore this term because it's smaller. If I put in 1 here, I get 12 minus 72, which is negative. If I put in 1,000, again, I get something positive. So positive, negative, positive, and I get up, down, up. So again, this must absolutely be labeled. Otherwise, I'm not going to have a clue of what you're doing. Even if you know what you're doing, I need to know you know what you're doing. And so now this is the relevant information. I'm listing it out here so that I can make my graph. I need the slope chart, I need the double prime chart, and the critical points and the inflection points. I made my crazy scale. It's not going to look very nice. And I first plot all the critical points. It's a little messy with this scale, but this is the point right here. This point right here is this point right here. This point right here is this point right here. And the last one, I started running out of a room. I put an asterisk here. It's the asterisk point right here. So these are the three critical points labeled. Then I make the graph do what is, I am missing my arrow here. This is going down and then up and then down and then up. Down up to the first critical point, then up to the next critical point, then down and then up. So it's doing this shape, down, up, on my graph. Again, the arrow didn't copy and paste over. This arrow here should be down. From here, I see my local max and local min. Local max is the little poobah over here, and the local mins, I have two local mins, this point right here and this point right here. I also have inflection points. The inflection point is at 0. Here's 0, 3. Didn't draw it nice enough. It should be a little bit higher, I guess. There it twists around, and then at 6, minus 788, I also get a twist. So it goes from concave up to concave down to concave up, and these are the switch points right here. Here's one switch point, and here's another switch point. And so those are my inflection points. Hope that clears up some. I know this is hard, it's lengthy, but you do have to, this is one you have to practice, and there's practice problems I've posted online with solutions so you can see if you're doing them right.